Hello everybody and welcome again to this course. This is Module 3 and in this third and final lesson we'll learn how the SPI and the I2C connections work.
In particular, this video will focus on the SPI and I2C protocols, the most important communication protocols that the Arduino boards provide and the most used to communicate with external devices in addition to the serial communication. I will start with the SPI protocol. Serial Peripheral Interface (SPI) is a synchronous serial data protocol used by microcontrollers for communicating with one or more peripheral devices quickly over a short distance. It can be also used for communication between two microcontrollers. With an SPI connection, there is always one master device which controls the slave devices. The communication over this bus is full duplex. Typically, there are three lines common to all devices: master in, slave out, the slave line for sending data to the master out, slave in, the master line for sending data to the peripheral, and serial clock, the clock pulses that synchronize data transmission generated by the master, and one line specific for every device, the slave select, which is defined on each device that the master can use to enable and disable specific devices. It is a synchronous serial data bus. Data can travel in both directions at the same time. Data travels back and forth along the data lines between of Arduino and the SPI device. This can only happen when the slave select line is set to low. In other words, to communicate with a particular SPI device on the bus, we set the slave select line to that device to low. Then we can start communicating with it. Then set the line back to high. The SPI standard is loose and each device implemented a little differently. This means that you have to pay special attention to the device datasheet when writing your code. There are four modes of transmission. These modes control whether data is shifted in and out on the rising or falling edge of the data clock signal, called the clock phase, and whether the clock is idle when the high or low, called the clock polarity. In addition, we need to specify whether the data is shifted in most significant bit or least significant bit, and the bus speed used. After that, we can start the transmission by the call of begin transaction methods. To provide a real-world example using the SPI protocol, we will use a common SD card adapter. This adapter is powered by 5 volts and can be connected to one of the 5 volts port of the Arduino board. Then we connect the remaining lines as seen in the picture. In this example, an Arduino Mega is used. Please check your Arduino board and make sure that you are using the correct pins connecting the adapter. Once it is connected, it is time to program a test sketch. With this program available in the course documentation, we will use a special library to interact with the SD card. Always check the datasheet of the external device to know the existence of specific libraries that make easy the interaction with the external device. In this case, we are also using a serial connection with the PC at the same time to check the debug messages. Open the serial monitor will allow us to see if the SD card adapter connection is working and the card is detected. Further use of this adapter will be shown in the upcoming chapters. Now let's focus on the I2C protocol, another popular protocol that allows external device connection in our Arduino boards. We will see the main difference and advantages over the previously discussed methods of communication. The I2C communication bus is very popular and broadly used by many electronic devices because it can be easily implemented in many electronic designs. The easy implementation comes with the fact that only 2 wires are required for communication between several devices. I2C is also serial and uses 2 pins but works completely different than asynchronous serials. So why to use I2C? That is because it has the best of the 2 previously presented protocols, serial ports and inherent switch to communication between 2 and only 2 devices. In addition, unlike SPI, I2C can support a multi-master system, allowing more than one master to communicate with all devices on the bus. The hardware required to implement I2C is more complex than SPI, but less than asynchronous serial. It can be trivially implemented in software. Each device has a unique address. Each device has a present ID or a unique device address, so the master can choose with which devices will be communicating. So sending data from our Arduino to the I2C devices requires two things: the unique device address and at least 1 byte of data to send. There are two ways to know the address of the device we want to talk with: by looking into the datasheet or using an I2C scanner. This is what we are going to use in the following example. Before that, let's talk about the library that is used to allow communicating with the I2C protocol. This is the wire library, and it has the basic function that start, read, write, and close a connection. Please check the references webpage for further details. For this example, we will use the I2C scanner program to see the I2C bus working. To get started, we can use any I2C device. This device has an internal address that we will figure out with this example program. Also, as said before, we can connect several devices at the same time. We need to mount the 4-wire connection in the I2C protocol. This includes the data line, the clock line, and the power. Note that 2 pull-up resistors are required. Often, these resistors are already present into the slave device board. Please check the datasheet to figure out if they are needed. As in this example we are using the Arduino Mega board, the lines are located at pins 20 and 21. Now we need to compile and upload the sketch to our Arduino board, selecting the correct COM port and opening the serial monitor to check the status of the execution progress. If an I2C device is successfully connected to the board, its device address will show up in the serial monitor. This example proves the I2C connection, and it is a very common process to start with a new I2C device. More complex sketches will be performed in upcoming chapters. Thank you. I hope you to find this new module very interesting. See you soon.